Hello everyone. So today our group want to present about power generation in electrical system. So this is my group mates. So first my name is THANESHWARAN KRISHNAN. My other group names name is KAILAASNAATH, Naidu and SHARWIN KUMAR. So first of all I would like to explain the biomass sources which all come from organic materials. We get biomass from forestry, residential industrial waste, and agriculture crops. Animal manure and sewage can also waste produce biomass, while municipal solid waste like food scraps can be converted into energy instead of being a landfill altogether. These sources help us turn everyday waste into clean, renewable energy, supporting a more sustainable future. From biomass, we choose to focus on the power plant option. So, what is biomass power plant? It generates electricity using organic materials like wood waste and agriculture residues. The biomass is burned to produce steam which spins a turbine to create power. Since the fuel is renewable, it reduces waste and lower our dependence on fossil fuels, making it cleaner and more sustainable energy option.
Heating system works in a household. First, wood pellets are delivered by a truck and blown into a storage room. These pellets act as the fuel source. Next, the pellets are fed automatically into the pellet boiler, where they are burned to produce heat. This heat is transferred to a buffer tank, which stores hot water. From the buffer tank, hot water is supplied to two places: the tap for domestic use and the radiators for space heating inside the house. The system is efficient because it uses renewable biomass pellets, which produce far less carbon emissions compared to fossil fuels. It also operates automatically, making it convenient and reliable for home heating. This diagram explains the basic working principle of a biomass power plant. Biomass such as wood chips or agriculture waste is fed into the combustion chamber. Air is supplied and the fuel burns to produce heat. The heat is used in the boiler to convert water into high pressure steam. The steam then flows to the turbine, causing it to spin. When the turbine rotates, it drives the generator which produces electricity. The generated electricity is then sent through transmission lines and distributed to customers. Biomass power plants are important because they turn organic waste into useful energy, reduce landfill disposal, and support renewable electricity generation.
So this diagram shows how an industrial biomass boiler system works. It starts with the chipper wood chipper on the left, where raw biomass such as wood logs is chopped into smaller chips. These chips are then stored in the fuel store. Next, the auger and agitator automatically move the biomass from the fuel store into the biomass boiler. Inside the boiler, the biomass is burned to produce heat. The heat is transferred to the buffer tank filled with water. The hot water from the tank is then circulated through heating coils or radiator to provide space heating. At the same time, the system can deliver hot water from industrial or domestic use. Overall, an industrial biomass boiler is a clean and renewable heating system. It reduces reliance on fossil fuels, uses waste biomass efficiently, and provides continuous heat and hot water for large facilities. Next, construction on biomass power plant. So, when a biomass is burned in the boiler, it produces fuel gases that contain ash particles, dust, and other pollutants. If these gases were released directly into the air, they could cause environmental problems. So, before the flue gas exits the chimney, it goes through several cleaning stages. The first equipment used is usually a cyclone separator. This device removes large and heavier ash particles by forcing the gas to spin in a circular motion. The spinning action throws the particles to the outer walls where they fall into collection bin. Next, the gas moves to an electrostatic precipitator or ESP. This is a more advanced system that uses electrical charges to trap the tiny particles that the cyclone could not remove. The particles get attracted to the metal plates and are shaken off periodically to the collected as ash. Finally, the gas passes through the back filter, also known as fabric filter. These filters act like a giant vacuum cleaner, capturing any remaining fine dust or pollutant. This ensure that almost all particles remove before the gas leaves the plant. By using these three main stages, the cyclone separator, the ESP, and the back filter, the flue gas become much cleaner. This reduces air pollution, meets environmental regulations, and makes the biomass power plant more sustainable.
Now, I would like to share a real example of a biomass power plant in Malaysia, which is the ETA Green Biomass Energy Plant located in Perak. This plant focuses on converting empty wood fractures or EFB into renewable electricity. EFB is one of the largest waste material produced by our palm oil industry. Normally, EFB creates disposal problems, produces methane during decomposition, and contributes to pollution. ETA Green addresses this issue by turning the waste into energy. The plant is built on about 18 acres of land located roughly 120 kilometers north of Kuala Lumpur. It is designed to handle large volumes of biomass up to 1,200 tons of EFB every single day. All this material is collected from nearby palm oil mills, reducing transportation distance and supporting a circular economy within the agriculture sector. Inside the plant, the EFB is processed, dried, and fed into a biomass boiler. The boiler produces steam which drives a turbine and generates up about 12.5 megawatts of electricity. This electricity is exported to the national grid, contributing to Malaysia's renewable energy targeting and reducing our dependence on fossil fuels. What ETA Green stands out is that it's not just a power plant. It also practices a zero waste concept. Besides electricity, the plant produces valuable byproducts such as fertilizer, EFB fiber, and pellets that can be used for industrial applications. By recovering these materials, the plant reduces environmental pollution and improves the sustainability of palm oil waste management. In summary, green biomass power plant is a strong example of how agricultural waste can be turned into clean energy. It supports renewable energy developments, reduces carbon emissions, and transforms palm oil byproducts into useful resources. This makes it an important model for Malaysia's future in sustainability energy. As a conclusion, with proper design, pollution control system, and responsible management, biomass power plants can contribute significantly to a greener and more sustainable energy to the future. Thank you.